Hey yo, Keeney coming to you with another case study. So we've got a 2008 Pathfinder in the garage this evening. Complaint is a fuse in the underhood fuse box keeps blowing. I don't have a whole lot more information than that other than they were driving down the road and it lost power, died, and then was a crank no start. So right now it'll crank over pretty fast. It sounds normal during cranking. When you key on, just pushing it into the lift. I did not see a check engine light, so perhaps we were losing power to the engine controller somewhere. And there's been a couple new parts installed for I think other concerns. It's got fuel pump crank sensor and ignition coils or end plugs. It looks like. So other than that info, I really don't have anything else that I know about the vehicle. So figured we drag you along on this one and see where she goes. Went ahead and jumped in the car, keyed it on, got all of these lights on, and I do not see a check engine light. With the key on, the engine fan is also running continuously. Went to give it a DTC scan. It would not auto ID the vehicle. I had to type in the VIN. And we have several modules that are not responding, including the engine controller. There's no response from engine controller. Into our list view, see what most of these codes are. It's like we have I don't know, for some reason my resolution or the brightness on the screen is very dim. We've got transmission says CAN communication circuit, starter relay, and a TP sensor. ABS says steering angle sensor and CAN communication. The meter says CAN. The BCM says CAN. No data, no data. Battery voltage, vehicle speed signal error, IPDM, CAN error. So lots of COM codes currently, which is interesting. This is what I know here. Let's go to the fuse box next. Under the hood of the fuse box, looks like this fourth fuse down is our EGI fuse on the top row. That's the one that they said kept blowing. So 1, 2, 3. Some very loud motorcycles driving by. Fourth fuse, EGI fuse, does not exist. I'm assuming there's still a problem in there. So we're going to jump into service info, look at some diagrams, come up with a plan of attack, and move forward from there. Sitting here going through service info. Apparently it has been a while since I've played with a Nissan because I forgot how much fun the service info is with these guys sometimes. But in any case, here we've got our breakout of our fuse box or our IPDM, whatever they call it, Intelligent Power Distribution Module. In here, we're looking at our fuses. We can see we only have two 20 amp fuses, one for the EGI, one for the ETC. I can never remember what EGI stands for, but this is, well, until I looked it up. This is supposed to be the Nissan electronic gas injection or something. So if we run, what is it? I just Googled it, got a light in the way. Google says electronic gas injection. So we're just going to go with electronic gas injection is what that means. One of the other things in looking at this fuse box cover, which is a bit annoying, yes, we have the orientation of how it shows in vehicle, and we have the amperage rating and the description for each fuse, but what we do not have is a number set associated with each one of these. So in like the GMs or whatever, a lot of manufacturers will have F1, F2, F3 for the fuse numbers, so on and so forth. This does not have that, and the reason that becomes an issue is when we go to the service info. I'll try to adjust this. The service info does not tell us we have an EGI fuse when we go to the IPDM. If I zoom in here, There are only two 20 amp fuses in here. One we can see goes to throttle control, the other one goes to ECM relay. And if we look in closer here, this is how we have to get confirmation of our fuse number. So it tells us it's a 20 amp, it's the ECM, not the EGI, but it's supposed to be the same thing. And then we can follow this on out. Another site, when I was just looking through the acronyms, I just Googled this site and it has a list of most Nissan specific acronyms. So this was also very helpful in looking through a few other diagrams. I'll post a link up for this in the description if you guys work on many Nissans. From that case, we're just going to bump on down to the rest of this ECM/EGI relay. There's our fuse number 53 that we saw previous, goes up here, and we got our output. So we're going to jump over to this relay, get a relay breakout fixture that I've got, and start doing some testing at the relay, see what this relay looks like. And continuing through a little bit of our Nissan service info saga, there is in service data a abbreviations page, and of course none of the abbreviations that we are looking for exist here, so it's more or less useless. But we're trying to now find where we left off last time. We're trying to find this ECM relay, and nowhere in this service info that I can find is there a layout of which relay in the IPDM is the ECM relay. Even when we look in the cover, we've got something that says horn relay, but the rest of all of these words are for various other fuses and potentially some trailer tow relays, but nothing that actually says that I can see very clearly is the ECM relay. So we're going to try to put a couple things together. We can see here, coming out of the IPDM, we've got pins 7, 4, and 3, but we don't actually know what connector it is. In jumping to the non-OE wiring diagram at our ECM relay, you can see we've got, it at least tells us connector 1, or E119, tells us 4, 3, and 7, which does match our 4, 3, and 7 wires coming out of this diagram. So at this point, what I'm going to probably do is go to this fuse. Actually, we're going to do two things. The intermediate step I did was Google it, just to see if Google has something. It does look like Google has something over here. We've got a box that looks very similar to the one in the vehicle, and it says ECM relay is this one. But to confirm that this is in fact the ECM relay we are after, I'm going to have to take a couple extra steps. So if we go to this page, the IPDM page, we've got the two halves of our IPDM fuses and relays. And then down here we have this disjointed block diagram. And here at the top we can see connector E119. So we're getting in the right area. And if we go over here to the right, we can see we have pin 7 ECM relay and pin 4 ECM and pin 3 ignition coil. We can make an assumption that 3, 4, and 7, these are the ones we're going to, because these three in this wiring diagram do run down to the engine controller. So we're going to first pull this fuse. I'm going to do a continuity check between this fuse number 53 or 20 amp and the pins of this ECM relay, and I should have direct continuity between these with the relay removed, the fuse is still removed, just to make sure we're looking at the right relay. And then afterwards, we're going to do a continuity check from these pins on connector E119 to the engine controller and see if in fact they do connect to each other, and just to make sure we're going on the right pins on the engine controller, as well as confirming wire colors to see what actual colors these are. So now we'll go and jump on the vehicle. Jump into the car now. We've got our corner relay pulled out here that Google said to throw on. I've got a little pedestal extender that I'm going to throw on here just to access these pins a little bit better or more easily for our continuity checks. It's kind of tight around all those wires. Looking at our wiring diagrams, or lack thereof, so it says connector E119. We've got E119 pulled up. It is an 8-pin across, I believe, or a 9-pin. 1, 2, 3, 4, 5, 6, 7, 8. It's a 9-pin across. One of them has a couple skip sockets. Looks like a 4 and a 3. And it is white in color. I'm not going to move that camera. And looking at this connector right here, I can see we've got 9 pins going across on this side. On this side, we've got our 4 sockets, our skip, and our 3 on that side. So it looks like we're looking at this one for the connector. We've got our actual fuse right there. Let's double check what wires we've got going here. So pins, can't see nothing, huh? Pins 3, 4, and 7. Let's just start with 3. This one says it's brown. This one says pin 3 is green. But our pin assortment looks like it is the corner one with the 3 pins out. So the corner one with our 3, it is in fact green. I do not see a tracer. So it looks like brown is wrong. We're gonna scratch that off and put green in there. Looks like pin 3 green is good here. Let's check pin 4 next for the color, which will be the one right next to it. It is in fact pink. I do not see a tracer on it either. So we've got pink. So now we're 2 for this one. This one's wrong again. Get rid of that pink. And then we'll move to, probably can't see nothing again. Move to pin number 7. That is going to be moving the opposite way from our skip sockets, then 6 and 7. So 6 and 7. We have a brown wire there. So WB is not wrong again, is wrong again. We've got a brown. So it looks like we're dealing with this one today. We're just going to throw this OE diagram in the trash because that's about all it's worth, straight from Nissan. Thanks, guys. We'll just deal with this one for now. So we're going to go ahead and do our continuity checks. We've got our fuse 53 pulled out because it was never existed in there. So I'm going to jump across these really quick and I'll let you know what I find. So we do have continuity between that missing fuse and the relay that we pulled. So from the fuse out, I get a continuity to this pin of the relay and continuity to this pin of the relay, less than like 1/10 of an ohm to each. So we know we're at least on the right relay to start doing the rest of our checks for the system to figure out why this thing is overcurrenting and causing issues. All right, I do not remember where I left off. I had a bunch of mental rabbit trails that we ran down. So just to catch you up, last time we were checking continuity between the fuse and the relay. We've got it on. We've got it there. The next thing, I want to just check this control leg of the relay. This control leg goes to the PCM for ground. I don't see any issue on this leg here, so we did a continuity check from this pin to the pin at the PCM, and it's fine. There's no issues there. There's no shorts, and it makes sense. Our current, especially with this relay resistor having it's like 160 ohms or something on this side, quite a bit. I checked several of these other relays in this box, and they've all got about 160 ohms of resistance. So makes sense. There's not going to be any issue on this side because we've got that voltage drop as expected. So we are moving on to these two wires for the load side of the relay. They branch off pretty much to everywhere. So they do go down to the PCM, but they also branch to several different components. Let me see. I don't remember what I did with it. Maybe it was this one. So it's got it listed here at the bottom. So we've got ECM, mass airflow, evap canister purge, solenoid, canister control valve, intake valve timing. So we've got a lot of fairly heavy load items coming off of these two legs of the relay that come from these two wires. So what I'm going to do right now, I input a breaker, a thermal breaker where this fuse goes. It's a 20 amp breaker. So if we exceed 20 amps, we should pop that breaker, and then after a few minutes of cooling off, it'll reset itself automatically. I'm going to see what our current flow is across this fuse, and then if we're getting pretty close to that 20 amps, I'm then going to jump between these two wires and see which has our high current draw across these two, and then start tracing these throughout. So let's jump over to the scope, because that's what I got hooked up. Okay, jumping in the vehicle, we're going to go ahead and key on. Last time we had no check engine light, fans are running, all the other lights are on. Let's see what happens. Oh, we do have a service engine light now, so we are powering up the engine controller. Our scope, this is inverted, and we are, oops, okay. Well, that was pretty fast. Let me pause this. I know the camera work is just wonderful. I try not to melt some wires. Here's what we saw. We've got the amp clamp going the wrong way every time. Let me flip this around so it makes more sense. So here's what we got. As soon as we key on, we're pulling about, we'll call it 13.5 amps. Runs for a little bit, then jumps up to about 20 amps, and then continues 20 amps all the way up to when I saw the trace going off of the screen. That was when I shut the key back off, so we could hopefully not fry anything. But it looks like this issue is present right now, which is good. So we're going to jump back and forth and pull each one of those relay wires across individually and do the same test and see what we come up with. Well, I'm down here on the floor because we have just unlocked SideQuest leaking fuel on the ground. I'm not really sure what we're going to do at this point. Seems whenever the ECM powers up, we start to send fuel up, and it's leaking from somewhere back here on the tank. It's getting to be a little adventure. We're going to figure out how we can deal with this. Perhaps we'll just do short key on and key offs and put an absorbent mat down here. We'll get the fire extinguishers out, because if we can at least trace down that short just with a quick key on, key off by doing our amp clamp tracking, I think we'll be okay back here. I'm not going to start it until we get this fuel thing wrapped up. But anyway, we've engaged a side quest. We'll now jump back to the electrical stuff. All right, back in the car. We now have the amp clamp connected around our pink wire. We're going to go ahead and key this on real quick. Actually, I'm going to let this trace reset on the screen. And then when it comes across, we'll jump the key on. We have very little current draw. Okay. I'm going to go ahead and turn it off. Now let's go ahead. It tells me hopefully our pink wire is actually doing okay. Now let's go jump over to our green wire. We're now set up with that clamp on our green wire. Go ahead and key it on again as soon as this trace resets. And of course we are inverted again. I'm going to go ahead and key off. Let's stop this trace. I'm surprised. Well, actually, I didn't even look close enough to see if I inverted on the last one. There she is. We now have our wire drawing all of our amperage. The initial kick on, or initial spike here, is about 17 amps. By the time we keyed off, we're already up to 23.5 amps. We got our wire. Let's go back to the wiring diagram and figure out where this green wire ends up. I don't know if you guys can actually see what is on the screen or not, but in any case, we got our green wire. It goes to everything on the car. We've got condenser top of engine, we've got ignition coils, we've got intake valve timing control solenoid bank 2, we've got intake valve timing control solenoid bank 1, and actually looks like that might be up. Nope, we also have the evap canister vent control under the vehicle. So we got a few components. I guess we will just roll the dice on, I don't know, which one do we think is shorted? Maybe let's just start here at the condenser, then we'll go on to the coils, and then the valve timing stuff. It's all under the engine. Let's go do that, and we'll start tracing these out for our current draw one at a time until we find her. Alright, as we continue to play mechanic, we go into our ignition system, ignition coil locations, and look at our connector views, and then we just have these pretty little pictures to look at. Here in this top one, make our adjustments. In this top right picture, it looks like here is our condenser, which is what we're going to go after first because it says condenser top of engine. Oops. Well, I already lost there it is. So back here it looks like we're going to be in the back driver's side firewall, and it looks like it's going to be inside of a harness. So we'll go back there, split that open, and see if we have hopefully matching wire colors. We're looking for a white and a black back there. Welcome back to the engine bay. Poking around the back side of this harness. I don't know how well you're going to be able to see this, but we will do what we can. Looks like we've got this doohickey taped on back here. See if we can't split the little bit of tape that's holding on. And we're looking for a, well, I already forgot the colors. I think it was a black and a white or a black and a green. I don't really remember. But we'll see what colors we got here, and we'll, perhaps not that it matters since we have incorrect wire colors all over the place anyway, but we're using the non-OE diagram for our colors now. All kinds of dielectric grease. Looks like we have a white and a black. And as far as I understand, this condenser is supposed to just be like a capacitor for our ignition system. If we do recall also, I think at the beginning of the video I said that the owner had installed ignition coils because he thought it was misfiring. I don't know what type of coils are installed or from where. But I'm just going to try to trim as much of this up as I can to get an amp clamp on it. And we will keep on trucking. I'll probably just edit this, so see if I can't snap my fingers and get you guys where we're doing something more interesting than pull this little harness out. Oh, no, we actually got it. All right, well, actually now I'm going to Gonna grab the amp clamp. We're gonna hook up to here and see what we got. Okay, back in the vehicle. Amp clamp is hooked up to the black wire on the condenser. We'll just key it on. And looks like we have no change. So, based on that, we are at the wrong component. Let's keep going. Intake valve, timing solenoid, bank 2. Key on. Nothing. Evap vent valve. Dang it. It's a different day. I don't know where I left off last exactly. But update on the Nissan. It's fixed. And not on purpose. It seems whatever I touched fixed it. So last we left off, I think we were doing some current draw checks on the different components of the ECM relay on our green wire. And somewhere in the midst of that, it started to smell a little bit of fuel. Saw like a drop or two on the ground. And then somewhere in there, also just unplugged the fuel pump relay. Looks like the line is starting to separate, the actual fuel supply line is starting to separate from the fuel sender inside the tank. If I recall notes, I do believe the owner put a fuel pump in this at some point in time, so perhaps that line just didn't connect it up the same. Either way, let's get back to electrical stuff. So the reason I did that is because I wanted to leave the key on while I started to do some more checks. In that recap, we were doing different checks. We had amp clamp on different parts of the circuit, keyed on, watched our amperage rise up. After a few of those, we started to not have an amperage increase like we saw in the beginning. I'm going to throw probably a screenshot in front of my face because I can figure out how to do that now. Where when we key on, we have a ramp and then it goes up to, I forget, like 30 amps or something like that on a 20 amp circuit. And so that's where that was on the green wire. And that's why we started going through the different components of there. What I made a mistake. What I should have done is more intermediary checks to say, the way I started when we had that screenshot that I just put in front of my face, we were using one of the AES Wave fuse loops, which these are awesome, by the way. And you can put a fuse in one end, but instead of a fuse, I put a breaker in there so that it would reset. And then you just clamp around that. This is when we saw the 30 amps or whatever it was. As I started to go to each individual component on that green wire, what I should have done is after each component, return to this and see if I still had the draw here at the fuse as opposed to the circuit. And the reason that matters is something I touched made the issue go away. I'm inclined to believe that it is the ignition coil condenser, which is this doohickey, which is just a capacitor. It says it's a 2.2 microfarad capacitor. When I do capacitance reading on it, it's at like 2.1 or 2.07, somewhere around 2.1. So not quite 2.2, but it's also like, what is it, 2% off? It's pretty close. I couldn't find any actual tolerance specs for this. But what I did find, and I will see if I can do another picture in front of my face. In the actual connector, there's a whole bunch of dielectric grease. And from what I understand, that's fairly normal. They pack these things with all kinds of dielectric grease to reduce any type of issue. When I look at the wire side of that connector, where the actual wires come into the back of the connector, the dielectric grease is white in color. When we look at the pins from the front and the pins where it plugs into the capacitor, there is white and green. And at first, I typically have seen which is probably a long time ago, but I've known these types of things get just overloaded with dielectric grease, and I just brushed it off as green dielectric grease. What I actually think it is, after going through this process and looking a little bit closer, I think all the dielectric grease is white, and I think this actually started to corrode and bleed into the dielectric grease, and that's why it is green. I do believe that is where our green is coming from. All that to say, what I should have done is, when we had our 30 amp draw with this, and then I should have gone to one component, hooked my amp clamp up. We understand that, as we saw, there's no 30 amp draw on a given component that I checked. I should have returned to this to see if what I just touched fixed it. I did not. I just went from component to component, and none of them had the draw. And I eventually went back to the fuse. None of them had the draw. So then, where the fuel thing matters, I wanted to be able to leave the key on because the condition was fixed. So pulled the fuel pump fuse so we're not pouring fuel on the ground, left the key on, went back through all of the different components that I checked individually, wiggled wires, wiggled this, pushed it in and out, tried to tap on it a little bit. Nothing is bringing this issue back, so it's fixed. I don't have a great answer as to what it actually was. This was like, I think, $17 or something from a dealer. So the customer is deciding whether or not he wants to take the vehicle back and fix the fuel issue himself, or if he wants to have me drop the tank, reconnect it, and then if that's the case, we can get the engine to run. We'll probably swap one of these in there also at the same time, and then we can get a confirmation video, but I don't know if that's going to show up. But all that to say, it's fixed, and I should have come back incrementally to the loop after touching each thing. That's really all I got for you. If for some reason we do end up doing more work to it and the owner doesn't want to fix the rest of it himself, I think he also is going to want to replace this himself. We'll continue on this video, but that's all I really got for you. I hope this is helpful for somebody. If you're blowing that EGI fuse, I'll try to put that in the description so people can find it easier. Perhaps check this thing out. And yeah, that's it. That's all I got for you. I'll catch y'all in the next one.